Students, in this class we will learn about differential equations. Now, there are two important terms you have to know whenever you are studying differential equations. The first term is called the order. The second term is called the degree. Now, what exactly is the order? The order of a differential equation is the highest order derivative. Okay, this is a very important word, is the highest order derivative present in the differential equations. Okay, now degree. What is degree? If a differential equation is expressible, very important word is expressible in a polynomial form, then the integral power, the keyword is integral power, of the highest order derivative appears, is called the degree of the differential equation. So let us understand what exactly does it mean, the order of differential equation. Now suppose you have something like this, say d squared y divided by dx squared, positive dy over dx, positive 7 is equal to 0. This is a differential equation. Now the derivative which you see here, the one which has got the maximum power, that power which you see here, that would represent what is called as the order. So the order of the differential equation in this case is 2. Now if the differential equation is expressible, the key word is if you are able to express the given differential equation in polynomial form, then the integral power of the highest order derivative, so whatever that is present on the head of this highest order, that is called as the degree of the differential equation. So in this case the order is 2, but the degree is 1. You follow me? So you have to start with the order and then get the degree. Have that in mind. Okay, we are given this question. We are expected to find the order and the degree. We have got 3y squared times dy over dx raised to the power 3 negative d squared y divided by dx squared is equal to sine x squared. Now this is first of all a differential equations. Now the order, look for the order. That means you have to look into that derivative which has got the highest number. So this is dy over dx. The number that you see here is 1, but this is d squared y over dx squared. The number is 2. So that will give you the order. So the solution is, the order for this differential equation is 2. Next, can you represent this as a polynomial? Of course, I can start with this d squared y over dx squared followed by positive 3 times y squared dy over dx raised to the power 3, and then rewrite this as negative sine x squared is equal to 0. So this is the lead term because this is the highest differential. So you should always be able to represent the given differential equation in the polynomial fashion, with the first term being the differential term that involves the highest order. So I am able to do that. So it is expressible perfectly in a polynomial form. So find out the quantity in which this differential is raised, the power. In this case the power is actually 1. So that is going to be giving you what is called as a degree. So degree is going to be 1. So this will be the solution for this question. You're given this question, you're expected to find the order and the degree. Now foremost, you have to remove this square root symbol. Now to do that, what you got to do is you will have to square both sides. So squaring both sides, we get. So what would you get when you square both sides? You raise this to the power of 2. You raise this to the power of 2. The outcome will be the square root that you see here will get cancelled with the square, therefore giving you 1 positive dy over dx raised to the power 2 is equal to y squared times d cubed y divided by dx cubed raised to the power 2. Now I would want to represent this as a polynomial. So this is going to be y squared d cubed y divided by dx cubed raised to the power 2. You move this to the right, this is going to be negative. So it's going to be dy over dx raised to the power of 2, negative 1 is equal to 0. Now clearly the highest derivative that you can see here is d cubed y over dx cubed. So the order for this differential equation is 3. Now find out the power to which d cubed y over dx cubed is raised, and that is clearly 2. So this is going to be my answer. The degree is going to be 2, the order is going to be 3, so that completes the solution. So we are given the third question, sine of dy over dx positive d squared y divided by dx squared positive 3x is equal to 0. Now foremost you have to see here the derivative which is the highest in nature. So this is dy over dx, that means it's differentiating the y term only once. This is d squared y over dx squared, that means differentiation is taking place twice. So that is going to give me the order. So the order is 2. Now with regard to the degree, you have to first see if it can be expressed as a polynomial. Now clearly you have the presence of sine. Now this is actually sine of dy over dx. So this is featured within the sine component. So for sure you cannot express this as a polynomial, right? So your immediate conclusion should be the degree for the polynomial is not defined. The degree is not defined, okay? Because from the definition of a polynomial, you cannot have anything involving sine or e or log. You follow me? So that is the reason that the degree is not defined. Why is it not defined? Because you are unable to express the given differential equation in a polynomial form. So you're given the last question, e raised to the power d squared y over dx squared positive sine x times dy over dx. So find the order. Now what is the order for this differential equation? Now clearly whenever you are asked to find the order for a differential equation, you have to first locate that differential which has the maximum differentiation. This is just one differentiation, dy over dx, whereas this undergoes two differentiations, d squared y over dx squared. So clearly the order is going to be 2. Now when it comes to the degree, you have to first see if you can express the given differential equation as a polynomial. Okay, is it possible for this? No, it's impossible because you got sine here and you got exponential function here. So your evident answer should be degree is undefined. Okay, so this should be the solution for the question.